I'm sure that you're all going to agree with me that medicine, drug availability and potency have improved tremendously over the last century. However, that doesn't mean that there are not still obstacles that we need to overcome. For example, the ability to have a drug present only where it's needed and not all over the body. Decreasing this way the dose needed and minimizing the unwanted side effects due to the presence of the drug at healthy areas. Luckily, there is a method that can achieve all those tasks at once. This method is the use of drug carriers, and that's what my research is about. You can think of drug carriers as taxis for drugs if you like. They transfer a drug into the body, keeping it covered and protected during the journey, and letting it out only once it meets its final targeting point and nowhere else. The drug carriers that I'm using are called MOFs, which stands for Metal Organic Frameworks. They're clusters consisting of metal nodes connected with organic linkers, and their structure looks quite similar to this Escher painting behind me. They are robust, highly porous materials that can accommodate drugs into their pores in a similar way a sponge retains a liquid. Their size is so small that they can easily travel into the body through the bloodstream. For the purposes of my project, I load an anti-cancer drug into a non-toxic MOF, and then I attach groups at its outer surface that are recognized only by cancer cells. Then, I test the effect it has towards cancer cells and healthy cells. Even though my research is at an early stage, preliminary results look quite promising, as they show that my drug-loaded material kills only cancer cells, leaving healthy cells almost completely unaffected. There's no doubt, of course, that more research needs to be done in order to fully optimize this method. And this involves improving the targeting effect they have and increasing the drug loading capacity. However, I hope I was successful today introducing you to those materials that have very interesting biomedical applications and can prove to be a strong ally in our battle for a healthier future. Thank you.